Hello, everyone. Let's get started. Please download Laboratory 28 from Blackboard. And today we are going to learn regression models. Yeah, so we learned how to use a linear regression model in Laboratory 27. So today we are going to use it. And what's more, we need to learn how to use multiple regression models. So the first one, you need to, as usual, you need to run the first script to identify your host name, username, and current information. And input your name, our number, title, and date, okay? And today's example is a classic question. It's about the advertising and sales. It's a classic regression problem. So we have, suppose we have a data set about the spending on TV, radio, and newspaper advertisement, and the number of sales of for a specific product, we need to explore the relationships between the parameters and answer the questions. Can TV or radio or newspaper advertising spending predict the number of sales for the product? See, okay, so for the first three, they are similar, right? So for different parameters, TV or radio or newspaper predict the number of sales. And for the fourth one, we want to use the three of them, not the single one, but the three of them to predict the number. In this way, if we want to answer the fourth question, we need to use the multiple linear regression model, okay? And last one, so it's about which parameters is a better predictor of the sales number for the product. We need to answer these questions, okay? So first of all, we need to import necessary packages, NumPy, Pandas, Matplotlib, and the statistics, okay? Right, and wait maybe 3 seconds. Okay, next one, we need to have the data set, right? So in this way, we use a requests to download something, download the content from the website. So requests and you set the URL and get the requests.get. And after that, create a new CSV file, advertising CSV file, and store this content, okay? So as you see here, it's empty, right? There's no CSV file, but if you run it, maybe wait 2 seconds and refresh your folder, then you can check here. There's a file named advertising CSV file, right? So please make sure to write and get the advertising CSV file. And after that, we can do basic we can get the summary. First, we can get the sample of the advertising, right? So you can also click this one. So there are 4 columns, right? Like 200 rows and 4 columns. The first one is about TV spending on advertisement, radio advertisement, newspaper money, and the last one is about the sales, right? So we can use this way to do the prediction. So next one, we get the summary, the count in value, standard deviation, minimum and maximum, right? It's about how to describe this data frame. And next one is about you can store them in different variables. For instance, you can get the first column, second column, and last column. And perhaps on your labs, this is a newspaper, right? So you need to revise it to sales. But to be honest, you don't need to use these variables. So if you can just delete this cell, it doesn't matter. Yeah, because we will not use the variables in the following cells. Okay, so it doesn't matter. Just write. And next one is about to have an initial relationship analysis on the data frame, right? So we can get the covariance. As you see here, right? So covariance, so you see they are all have some relationships, they are positive, right? And you can also get the correlation coefficient. Here's a method, right? So Here's the method means if it is 1, then it is itself, right? And it's -1 is so it's a so if it is between 0 and 1, it means it's a positive relation, right? So they have some positive method, positive correlation, and if smaller than 10, it's negative. Smaller than 0, it's negative, right? So you can see sales is related to TV, radio, but for newspaper, it's very small, right? The correlation. And then but we cannot use them to show like they have some relationships. We need to define a model to answer it, okay? So any questions so far? Do you have any errors? Okay, next one is about the answer the first question. Okay. Hello? Okay. William, do you have questions? Okay. So answer the first question, can TV advertising spending predict the number of sales, right? So first we need to, as we did in Laboratory 27, we need to import statistics models, right? Formula API, SMF, and then OLS, so we need to initialize and feed linear regression model. The model name, it would be ordinary least squared, right? OLS method. And the next one, you need to have into the stat which one you want to predict and the predictor, right? So in this way, we'll predict the number of the cells, right? So it's the first one. And please make sure here is not the variables you defined here. It's not the variables. It's only the column names of the data frame, right? This is a data frame and the data frame cells. So that's why here S is in uppercases and TV, right? So it's about the column names, and please make sure to use the right name, initialize, and then train the model. After that, you can get the parameters about the linear regression model, the slope and the intercept, alpha and beta, right? So in this way, the intercept alpha would be 7.0, and then it is a beta, right? So you can use it. Actually, you can predict all the values, right? Actually, it's YE is like this way, multiply TV numbers and plus this way. Okay, so it is the model you generate from this one, right? And you can use this way to get all the predicted values. Then you plot them together. So let's read the codes. So last three is about X label, Y label, and title, right? It doesn't matter. So first one, you create a Canva, right? And next one here is about a scatter plot. So you need to use the DFTV as the X-axis, Y-axis, and O means this is, we want to have a dots. And we didn't set the color, so it's a default color, blue. The blue is a default color. And the regression line, we can set this as the X-axis and the predicted as the Y-axis, right? And R means red color, and the width set is as 2, okay? So set it's a result, okay? Scatter plot of the raw data, actual data in blue dots, and the linear regression line in a red line, okay? We see it's pretty good, but not the best one, right? You see some dots, they are far from the linear line, right? But this linear line can show the trend of the basic relationship between the TV spending and the sales, right? It's about how to analyze them. Answer the first question. Okay, so any questions so far? Okay, and the next one is about the radio. So it's very similar, right? First one, you need to import the statistics models first and use the OLS method, cells and radio, and get the feed parameters, right? And after that, you use the get the predicted values and do that again, set the canva and do the scatter plot with actual data and it's blue. And second one, you set the regression line and do that again, right? So see here, and actually here you can set the color. Color would be yellow. Let's set the yellow one, so it's a yellow one. And if you delete it, so it is blue, right? Blue by default. So that's why here is blue one, blue dots, and red lines. Red line, so you can use the yellow one. So yellow one, red line, but the red line looks better, right? So that's why we choose red line. So, but in this one, you see, it's not quite good, right? In this way, we see they are all surroundings, the scatter plots, they are surrounding this red line. But in this way, you see this dot is very far. This dot, they are all very far from the linear line. But it shows perhaps it's not only a single regression model. Okay, it's about the TV, radio, TV advertising and the radio advertising. Okay, so any questions so far? Okay, next one is the exercise 1. So you need to write the codes to answer the third question. So can newspaper advertising spending predicted the number of sales for the product? So you need to use, actually, I will give you some hints. So here you can use the code from the radio one, but the only difference here is not radio, right? It's newspaper. It's newspaper, right? Newspaper, let me check newspaper. Yeah, it's correct. It's the right one. And then you need to predict it. The prediction, news prediction. And after that, you plot them again. So you can plot here. All right. So under the blah, blah, blah by yourself. Okay. Please finish it by yourself. It's about the exercise 1. It's very, very similar to the first 2 questions because they are all single linear regression model, right? Only one parameter. Okay, it's about exercise 1. Any questions? Okay, so next one is about answer the 4th question. So clearly it's not the best fit to show to fit the model, right? So we have another question actually. So can we use 3 of them? Can we use TV, radio, and newspapers to predict the number of sales? Then we need to use a multiple linear regression model, more than one predictor. So it's modeled by this way, right? Estimated Y is alpha and beta 1 x1, beta 2 x2, beta p xp. P is number of parameters. So in this example, we have 3 parameters, right? So beta 1 to beta 3. That's why here the cells would be alpha is the intercept and beta 1 is TV, right? So here is the only answer the first question. So in this way, we only want to have a model like looks like this way, right? And in this one, we only want to find this way, right? And in this exercise, we want to find a newspaper, right? This way. But we can combine them together to get a multiple linear regression model. But please make sure here beta 1 is not the same as the slope in the single linear regression model. You need to train them again and get a new number, right? Sorry. And in this way, we need to use sklearn package. And if you are actually, it's a basic model in machine learning field, and sklearn is very, very important in machine learning in machine learning domain. Okay, so it's like only the basic model and the simplest model. So here from the sklearn linear model, you can get a linear regression model, and it is a multiple linear regression model. And after that, you can build the model using the TV, radio, and newspapers. You can use this way. Predictors and set as X is DF and Y, something you want to predict this way. And initialize about model and fit with X and Y. So here we can find the relationship between the cells and these three parameters. Okay, right. And after that, you can get all the numbers, values for this linear regression model. In this one, the intercept is alpha, and the coefficient is beta 1 to beta 3. Okay. See here, beta 1, alpha is intercept, and beta 1, they are slopes, right? Beta 1, beta 2, beta 3. So you can use this way to get the model, right? So it is model, cells is the intercept, and the multiply, plus the first one, TV, second one, radio, and the last one, newspaper, right? This way. And we can predict the sales from any combination of TV and radio and the newspaper costs. Okay, so, and based on this model, if you have this model does this one model, and you can predict any numbers. So for example, 300 in TV advertising, 200 radio, and 50 in newspaper, then you can use this way. Okay, so here this is a technique to ignore the warnings. Perhaps sometimes there may some have warnings, but they are not errors, so it won't affect the result of your codes. But they are annoying. You see some warning, right? And then see here new X and 300 for TV, radio, newspaper, and you can get a result from model.predict, and then it's the input and get the output. Okay, so it is 52, right? And in this raw data, actual data, they are all some actual numbers. So that's why here we need to use this model to predict something new, something they are not in this advertising CSV file, right? So we can use this model to do a lot of things. We have this model, then we can predict anything, right? So it's the answer to the fourth question. So how to generate a multiple linear regression model, and how to train it, and how to predict something. Okay, so please use the sklearn package. Okay. All right, so last question, last exercise. So please answer the final question. So which parameter is the better predictor of the numbers of cells for the product? So you for exercise 2, you don't need to write any codes. You just need to answer. Why do you think, perhaps you think the first one is better, and why is better? So please show your reasons, okay? Yeah, so, but for exercise 1, you need to write codes, okay? Here you need to write codes to answer the question, but for exercise 2, only your words, okay? Yeah. And one more question. So here is I'm not sure the plans after laboratory 28, the plan of next week, but I'm pretty sure perhaps you will have some bonus labs. For bonus labs, you are not required to attend the lab classes. Maybe I will upload some recordings, then you can watch the videos, and you can finish this bonus labs to get some bonus points. But if you are not interested in that, it's okay, because they are all bonus, right? Okay, but yeah, and for the projects, you can send me an email to answer or schedule a meeting with me about any questions. Okay, and I'm not sure they are bonus labs or normal labs, and I will let you know maybe on Sunday or early on next Monday. Okay, so I will send you one one more email to show the plan after laboratory 28. Okay. So yeah, so that's all I want to share today. If you don't have any other questions, please feel free to leave the meeting. Thank you guys. Have a nice weekend. Okay, sure, please. Okay, let me stop recording. Sorry.